everyone, today I'm gonna show you my timecode slate project, which might be the cheapest available. I always found them cool, actually didn't need one yet, but I like the challenge to make one from cheap parts. I used a slate from AliExpress to start. I 3D printed the buttons, but it is not necessary. You can see in other projects in more detail the mechanical bearing parts, so I skipped that. Be careful if you build a circuit on a protoboard, because at 810 or more megahertz frequency, funny things can happen if the loops are too large. At least the ground connection shall be as short as possible, the peak and the oscillator close together. The rest is more forgiving. So let's connect the battery and turn it on. I use 2S LiPo battery, which is cheap and can be charged very quickly. The consumption is about 15 milliamps when the slate is closed, meaning about 50 hours operating time. When the display is on, it's from 30 to 130 milliamps depending on the brightness set. The frame rate can be set to all standard values from 23.976 to 30 frames per second drop and non-drop. The hour and minute can be adjusted and the second and frame can be reset. There are 4 levels of brightness settings to adapt to the situation. There is a scene and take setting, which will be shown when the slate is closed, and it's also encoded into the user bits of the timecode, so can be used when editing. The take counter is automatically incremented at every opening of the slate. So let's check it with my F4 field recorder. First I connect the signal from the F4 to the input. The signal LED on the right shows that there is an incoming signal. Pressing the jam button will show the incoming timecode on the display. Frame rate doesn't matter now. Pressing the H button syncs the device to the incoming code. Any other button just exits the jam menu without changing for original time. And now let's connect the output to the input of the F4. I just change the time. The F4 will show the timecode we generate and the frame rate we set. So now this is how I assembled it. The display is the widely available TM1638 module with 8 LEDs, 8-digit display and 8 buttons. Micro switch detects the opening and closing, and I used a small single-sided protoboard to build a circuit around. Instead of the micro switch, you could also use a whole switch if you prefer. The display is about €3, the peak about €2, the TCXO is about 7 and battery is about 8, all including shipping and VAT. And I estimate the chicken food parts to be about €2 total, so it's around €22 total to build the circuit. Okay, you can also check the battery voltage. Now let's see the schematic. The circuit is very straightforward. Reverse protection diode, which is optional. If you use battery connector that prevents reverse connection, it's not necessary. And if you want to hot swap batteries, you can add a second battery with a second diode. Linear regulator provides stable 5 volt to the circuit. And it's important to have an electrolytic capacitor directly at the display, because its PWM can cause disturbance in the circuit if it's not shorted locally. We have a voltage divider R12 for the battery voltage measurement connected to the ADC on RA4. There's a small cap to reject the noise. There is the programming connector, then the TCXO and the PIC with a decoupling capacitor. The TCXO shall be 0.5 ppm accurate or better. Unfortunately, it will drift over time, so periodic calibration may be necessary if we want to stay true to the standard. I may add it in next design voltage control TCXO that can be calibrated in hardware. Okay, the TCXO signal is used by the timers to generate the output signal and to measure the input signal. The input is DC decoupled and pulled to about 2 volt and connected to the comparator input on RA1. The output signal comes from RC1 and has a divider to lower the logic signal and provide some protection. The division can be changed according to specific camera or recorder voltage levels needed. The slate switch is connected to RC0, which is programmed to have an internal pull-up, and there is a capacitor to eliminate the noises. So to sum up, I know it's not like the ones used in Hollywood. No fancy features like Bluetooth sync, just basic functionality, but I think it's more serious than many others that have no accurate time base and so cannot be actually used for the real purpose. If someone wants to sync to other units via radio, there are 433 MHz modules for a few dollars, and those can easily transfer the signal. So tell me what you think. It's not difficult to make the code in C, but if someone needs, I plan to sell program pics when the code is tested more. Probably also an assembled real PCB version with a bigger display. Okay, that's all. Thanks for watching. Have a nice day.